Okay, so I want to talk about the intuition of matrix multiplication now. So the reason why you cannot just simply multiply each element and get your final product is because of the reasoning as follows. So imagine you have three circles, and this is the domain. The first circle will be the domain of a function. And let's call the second circle, instead of calling it range, let's call it the codomain of a function. And if you really think about it, let's say there's a point here that you're mapping to a point here. This can be shown as a matrix times a vector. And a vector is just a one-column matrix. So let me give you an example. If I have the matrix B equals 0, 1, -1, 0. Sorry, the first one should be a 0. And if I multiply that by some 2-by-1 matrix that I'm calling a vector, based on what we showed you earlier, this would yield the following. Negative x1, and so this is a 2-by-2, and this is a 2-by-1. So the final output should be a 2-by-1. And the second one will look like this. Sorry, that should be next to next one. Okay, so what we've just shown here is that when you apply a matrix to a vector, or a one-column matrix, you get some output vector. And if you think about it, that's what a function is. It's something that takes something as an input and gives you something as an output. So back to our potato diagrams, I have an input to an output for the first two circles. Now, I'm going to call the second circle an input for a new function with matrix A. So I'm going to map, so I have my points, and just to be clear, there are also points right here. So now I'm going to take this point that it maps to, and now call that my new input vector, which then maps to another codomain. And we know that this is really B times the vector x. So this can really be represented as the matrix A times B of x. So you can see this is actually function composition. And based on associativity, you can then show that A, B, x vector, these are equivalent statements. And so the general intuition behind matrix multiplication is that it's really a composition of functions. So let's keep our matrix B the same as I defined it earlier, and let's make matrix A equal to 1, 0, 1, 2. So let's say that I passed in an input vector, and I got an output vector of 0, 1, which is the column of B. Right? This is a 2-by-1 matrix. And so when I do function composition from A, what I'm really doing is this. So AB equals A times the first column of B, which was 0, 1, and then A times -1, 0. And we know how to do matrix multiplication. Okay, so we have this, right? And this is function composition. And what we can do now is we know that A is a 2-by-2 matrix, and we know that 0, 1 is a 2-by-1 matrix, and same for this right side with -1, 0. And so we can just multiply them. And so we get AB, which is equal to 0, -1, 2, -1. And I didn't show the steps here, but you can do that for yourselves, and you'll see that this is really equivalent to this above statement right here. And so And this is also numerically equivalent to the method we showed you earlier, where you take the dot product of the rows and columns. So this is the general intuition behind matrix multiplication.
Thank you for watching this video about matrices. See you next time.